Okay, let's take a look at a second example. In this case, what I'm going to do is I'm going to combine two solutions together. And so I'm going to combine a solution of potassium hydroxide with a solution of sulfuric acid. And I've added them together so that we're at our equivalency point. First thing we need, though, always, we need our balanced equation. And because we're asked for our molar enthalpy of neutralization in terms of KOH, that helps us to know that my system is KOH. Again, we need to know my molar enthalpy, and I know that my enthalpy change is equal to my number of moles times my molar enthalpy. And in this case, because it's solutions, we know that my moles is equal to my concentration times volume. Okay, so that now this tells me what variables I need to know in terms of my given for my system. I need to know the concentration, the volume, and potentially the molar enthalpy of neutralization for KOH. Well, since the molar enthalpy of neutralization is what I'm looking for, this is my what unknown. Now, again, because I'm combining my two solutions together and the hydroxide ions are going to combine with the acidic protons to form my water, that is my reaction. The potassium ions and the sulfate ions are spectators, but more importantly, the water molecules that surround the hydroxide ions and the acidic protons are going to be my surrounding, because that's what's around the particles when they interact. And so the water is what's going to absorb or release the energy during this chemical change. So we need to know our information about our surroundings. Well, once again, because there's no change of state, Q is equal to mc times delta T, so this tells me what I need to know. I know C, I know my initial temperatures, I can get my temperature change. Again, I'm going with absolute values. Now the question is, what is my volume? Well, when I combine the two solutions together, that means that the water that's the surrounding for both of them is going to combine. So therefore, my volume that absorbs or releases all of the energy is the combined volume of the two solutions. Once again, I'm going to look, and in this case, my final temperature is greater than my initial temperature. This tells me that my surroundings has absorbed energy. So therefore, my system must have released it. So my system is exothermic. So my delta H will be equal to negative Q. Now, once again, I have two equations that equal delta H. So I'm going to look at combining them. And then I'm going to manipulate them. And now at this point, I can substitute in all of my values and solve for my unknown. So I substitute in all my values. Once again, I put in my units, because my units will help me to know what's going on. The kilojoules of water cancel with the kilojoules of water. Degrees Celsius cancels with degrees Celsius. Moles is left. Liters cancels with liters. So I'm left with kilojoules per mole. This tells me that I set up my equation correctly. This is why we want to use our units. And we solve for our final value.